Hello friends, today I will be going to show you how to make a drone with ESP32. When you download ESP IDF, you should download any version that is under the 4.4 version. I have downloaded 4.4.4. It would be beneficial for you if you download the 4.4.8 version because I have faced many errors with this version, which I have given the solution in the video. Now you can download ESP IDF from the above website. There are many versions that are available, but you have to select the ones which have version 4.4 as the initial release. I am selecting offline version 4.4.4. Now here are the softwares that I have downloaded. There is the ESP IDF, Git and Python 3.8. Now I will show how to clone the GitHub repos on your desktop. I am cloning it from my own GitHub repo because I have modified the barometer that was not supported in the original firmware. Now you can see that my repo has been downloaded into the ESP32 IDF folder. You can navigate to the folder that I have shown here. Now in the requirements folder, you can see all the required modules, the ESP32 module that are required to make the ESP drone. You can pause the video now and see the parts that are required to make this drone. Now I am navigating to the schematics folder where I have written all the connections that are need to be done with the modules and the ESP32 board. I am using ESP32 38-pin dev kit. You can use any board that you like. Now I am cloning the crazyflie client and the crazyflie library for Python, which I have cloned with my own repo. The official repository had some problems with PyQt5 and there was also missing DLL which I have added in my repository. Now I am fast forwarding this part. You can find all the commands in the description below. Now I have navigated into the bin folder in the crazyflie-clients-python. It should be running in a few moments. Now we have successfully launched the CF client. In the next part, I will be showing you how to connect the drone with the PC via Wi-Fi. For now, we will be focusing on how to develop the firmware for your ESP32 board, as you can customize any of the pins that you want for your motors and other sensors. You have to launch the ESP IDF once more and then navigate to the path that I have shown. Now I am navigating to my repo to open the schematics and then match all the pins with the config. Here you have to go to the repo directory that is saved in your ESP IDF folder. I accidentally launched the ESP IDF Menuconfig in this folder, which should not be the case. You have to go to the firmware folder and then launch the same command. Now I will be entering the same command as before, but as you will see that I will face some errors which I have fixed in the later part of the video. Here comes the error. As you will see that the IDF version as I am using has a older version of the IDF component manager. So we have to update the component manager by the command that it has given. We have to navigate to the following directory and then run that command by opening cmd. You will also have to run this command if you are using anything that is below IDF version 4.4.8, as the original repo was made with that IDF version only. After running the command, we again have to run the same command that we were using previously. This time we also faced an error. It is telling us to run the install.bat file in the ESP IDF folder. We will do it shortly. I have navigated to the folder and now I will run the install.bat. After the process is completed, it will automatically close the window. Now we will again run the same command on the original IDF window, and now the configuration menu will open up. Now we have to change the serial flasher config according to our board. The board I am using has a flash mode of DIO, so I am selecting DIO. It also has a flash size of 4 MB, so I will be selecting 4 MB. Now I will configure the ESP board. I am using the normal ESP32 version. If you are using any of the above, you have to select those. Here are other configs that you might need. In the wireless config, you can change the name of the drone and the password of the drone. In the calibration angle, you will be able to calibrate the pitch and roll. I am disabling the buzzer for now, as I have not used any buzzer. Now, I will be configuring the SDA, SCL and N pin of MPU 6050. Note that all the other pins that are used in the motors must not be present in the SPI or I2C pins. So I have edited those also. Now the board I am using has an inbuilt LED on pin 2, so I am selecting the blue LED to be on pin 2. In the motors config, you have to configure all the motor pins that you have used in your ESP module. I have used the following that are present in my schematic. You can use any of the pins that you want. After that, we have to press S on the keyboard to save. And after we have pressed S, you can toggle the enter or the space button to save the configuration. Now you can use the following command to flash your firmware into the drone. You just have to change the COM port number to suit your PC. First flashing will take a while. After the firmware has been flashed to your drone, you can connect it via USB to your PC and use the following command to monitor the output of your ESP32 drone. There, you can also debug any of the errors that you are having. So now, I have finished the complete tutorial of how to set up the software and how to install the firmware to your drone. In the next video, I will be showing you how to connect it to your PC, check the yaw, pitch and roll values, and then connect it to phone and fly test. If you don't want to use the barometer sensor, then you can just exclude this define so that you will be able to fly the drone with the MPU6050 only. As if you don't connect the MS5611 barometer module, then you won't be able to fly the drone if it is not commented out. For commenting it out, you can go to the following directory, open Notepad and then comment it out and then save it. Open this file in Notepad. After opening, you can just comment out the define sensors enable MS5611 and you are ready to go. For now, I am enabling the pressure sensor as I have included it in my drone. Thank you for watching my video. Be sure to subscribe and like and share this video to all your friends who have an ESP32 module and want to make a drone out of it, as it's a dream of many kids who want to make their own drone but are unable to do so because of the lack of flight controllers they have.